Hello everyone and welcome to the YouTube channel of Being ACCA. This is Tushita Gupta, ACCA affiliate, and in this video we are going to be solving the questions of section A from life cycle costing. So let's get started. The first question is: a company has produced the following information for a product that it is about to launch. The product is expected to have a life of 3 years. So we have the information given to us for 3 years: expected sales, variable cost, fixed cost, variable selling cost, fixed selling cost, and administrative cost. So we have to find out the life cycle cost per unit. So for life cycle cost, we need to find out first of all the total of all of these costs. So let's find out the total. So the total will be, first of all, I will take 2.3 multiplied by 2000. Then I will take 1.8 multiplied by 5000. And then I will take 1.2 multiplied by 7,000. So this will be my total of the variable production cost per unit for all 3 years. Then I will add my fixed production costs, which is 3,000 plus 3,500 plus 4,000. Then I will have 0.5 multiplied by 2000, because again these are variables, so these will be multiplied by the number of units. So 0.4 multiplied by 5000 units, and then for year 3 0.4 multiplied by 7000 units. So then I will add my fixed selling costs. So for each of these years, this is 1500 plus 1600 plus 1600, and then again I add my administrative costs: 700, 700 and 700. So if I total all of these figures up, I will get my total costs as 45,100. And if I divide this by the number of units to find out my per unit cost, so my number of units in total is 2000 plus 5000 is 7000 plus 7000 gives me 14,000. So my cost per unit becomes 45,100 divided by 14,000 units. And if I carry out this calculation, I will get my answer as 3.22. That makes option C the right answer. Moving on, a manufacturing company which produces a range of products has developed a budget for the life cycle of a new product P. The information relates exclusively to product P. We have to find out the budgeted life cycle cost per unit of product P. So let's find out. First of all, we have the design cost. Okay, direct manufacturing per unit is given, depreciation, decommissioning, machine hours, and then we also have our production and sales units. So it is said that the total fixed production overheads are budgeted to be 72 million each year, and the total machine hours are budgeted to be 96 million hours. The company absorbs overheads on a machine hour basis. So first of all, let's find out our overhead absorption rate. So this will be nothing but 72 million divided by 96. So that gives me $0.75 per hour as my absorption rate. Now, with regards to my manufacturing cost, it is mentioned that we are making 3,000 units, and this will be multiplied by 20 because this is my direct manufacturing cost. So if I add all of these up over here, so this is 300,000 multiplied by 20, and then to this I will add my depreciation cost as well as my design cost as well as my decommissioning cost. So 800,000 plus 500,000 and plus decommissioning is 20,000. I am taking all of these costs. Why? Because when we are looking at the level of the life cycle cost, we add all of the costs together. So then we take our fixed production overheads. So we have 300,000 units, and then for each unit we have 4 hours, and then we have 0.75 as our absorption rate. So the total, the fixed production overheads that we have is 300,000 multiplied by 4 hours and multiplied by 0.75. So this will be the total fixed production overheads that relate to product P, right? And then we add all of these costs that I've mentioned over here together, and adding all of these together will give me a cost of 8220,000. And if I divide this by the number of units, I will have the cost per unit. So the number of units is given to be 300,000. So if I divide this, I get my answer as 27.4. Moving on to the 50th question. S&T is a Japanese electronics giant specializing in the production of game consoles. So this is a very big case study. Which of the following statements made by the chief executive are true regarding the costs? So let's have a look. The cost per console calculated using the life cycle costing principles is higher than the price customers are prepared to pay. So first of all, let's find out the life cycle cost in total. So we have the R&D cost. So this is 950,000. I am calculating the total costs at one place. Right. So the total costs will be, first cost is the R&D, which is 950,000. Then to this, I will add my marketing costs, which is 230,000 plus 120,000 plus 20,000 plus 5,000. So with this, I have my marketing. Then I go for the production costs. So these are given in per unit, per console terms. So I will just have to multiply this with the number of consoles that we are going to be manufacturing and selling. So 450 multiplied by 10,000. Again, similarly for warranty, we will have to do the same. And then the end of life cost will be something that we add over here. So first of all, I can say that this is 450 multiplied by 10,000. Similarly, this will be performed for all of these. So this will become quite a big calculation over here. So 430 multiplied by 12,000. Then I have 290 multiplied by 11,100. Then I have 290 again multiplied by 3000. So these are quite big calculations, but the question otherwise is very easy, right? Then we have warranty costs also given in per console terms. So 30 multiplied by 10,000. 10,000 plus 30 multiplied by 12,000. Then again, I have $40 in third year, 11,100. Then I add my $45 multiplied by 3,000. So with this, I have come to an end to my warranty cost. Then end of life is 00, just 125,000 at the end. So if I add all of these costs together, I will get my total life cycle costs. And the total that I will get over here will come out to be 16438,000. So this is the total life cycle cost. Now, how many is my total number of units? 10,000 plus 12,000 plus 11,100 plus 3,000. The total of all of this will give me 36,100. So if I just divide this figure with 36,100, I will have my per unit cost, and my per unit cost will come out to be 455.35. Now let's read about what is said should be the selling price. So market research has indicated that customers will be prepared to pay an average price of 420. So the cost per console calculating using life cycle is higher than what customers are prepared to pay. So yes, that is why statement 1 is absolutely true. Customers are prepared to pay 420. Our life cycle cost is coming out to be 455.35, which is more than what customers are willing to pay. Now let's have a look at the second one. More attention to R&D costs in 20x0. R&D costs are over here. Could reduce the warranty costs in the later years. So yes, this is definitely true because R&D will reduce the defects that will arise in the future, and that is how warranty costs can also be reduced in the future. As you can see that these are increasing. This is first increase from 30 to 40, then to 45. So this can be reduced at the later stages if we are putting in, more efforts at the R&D in the beginning stage. So yes, statement 2 is also correct. This makes option D as the correct answer. Now let's move on to question number 51. I will just mark my answer over here that my answer is option D. Moving on. while a drag and drop question is impossible to fully replicate, okay, so we have to drag the options which are correct. We'll just tick them as of now. So we have to see which four of the following are said to be the benefits of life cycle costing. So it provides the true financial cost of a product. Definitely, yes, we are adding all the costs right from the beginning till the end. So that is why we can see the true financial cost. The length of the life cycle can be shortened. No, this is not a benefit. Expensive errors can be avoided, in that potentially failing products can be avoided. Definitely, yes, because when we are seeing the life cycle, we are seeing what are the errors that can possibly happen, and then we can reduce the possibility of those errors, and these can be definitely expensive errors. Then lower costs can be achieved earlier by designing out costs. Definitely, yes. If we know that this is the total budget, we can definitely work on controlling the costs also. Better selling prices can be set. Definitely, yes. When we know that how much is the total that we are spending on a product right from the scratch till the product goes to the end, then we can definitely set the selling prices also in a better manner. Decline stages can be avoided. Absolutely not. No stages can be avoided. Yes, some stages can be shortened or increased according to how we take our decisions, but no, nothing can be avoided. The decline will definitely happen. Okay, so now let's move to question 52. Which of the following statements are true regarding the justification of the use of life cycle costing? So let's have a look at statement A. The product life cycles are becoming increasingly short. This means that the initial costs are an increasingly important component in the product's overall cost. This is absolutely right. Now we see that trends are changing very fast. That is why products come and go. We see fast fashion also. So this statement is right. Moving to statement 2, product costs are increasingly weighted to the start of the product's life cycle, and to properly understand the profitability of a product, these costs must be matched to the ultimate revenues. Definitely, yes. When we are evaluating the products, it is always seen that in the initial stages we will have to incur more costs like research and development. So this is how life cycle costing is definitely a justification over here. So yes, this statement is also true. Moving on to the third one, the high costs, for example, research, design, and marketing in the early stages necessitate a high selling price. No, you may or may not sell a very high initial selling price. You may see that, okay, these are the sales that we can achieve later also. So you may distribute those high costs throughout the entire life of the product instead of charging a very high initial price. Traditional capital budgeting techniques do not attempt to minimize the costs or maximize the revenues over the product life cycle. Now, this statement is absolutely true. The deliberate attempt to maximize profitability is definitely the key to your life cycle costing. So 1, 2, and 4 are correct, which makes option A the answer. Moving to the next one, which of the following statements is true regarding the life cycle costing? Life cycle takes into account all costs incurred with exception of the sunk cost incurred on research and development. Now, this statement is false because we do take research and development costs also. Life cycle costing ensures a profit is generated over the life of the project. Definitely, yes. Life cycle costing is most useful for products with an even weighting of costs over their life. This is absolutely not true. Why? Because life cycle costing can also be used for those products where it is not necessary that costs are evenly weighted. We usually see that life cycle costing proves very useful even when there is a very high initial cost involved in the beginning of the life cycle. So option B is the correct answer over here. Now let's move on to question number 54. This is the last question. In next video, we will be starting with throughput accounting. Company B is about to start developing a new product on for its launch in existing market. They have a forecast sales of 20,000 units, and marketing department suggests a selling price of $43 per unit. The company seeks to make a markup of 40% product cost. It is estimated that the lifetime cost of the product will be as follows. We have to find out the life cycle cost per unit. Okay. So first of all, let's have a look. the selling price that we have given the selling price to us. So first of all, let's total all of the costs up. So 43,000 is my design and development. Then manufacturing is 15 per unit. How many units are we forecasting? 20,000. So 15 multiplied by 20,000 will give me my manufacturing costs, and then decommissioning is $30,000. So if I total all of these costs up, I will get 15 into 20,000 gives me 3 lakh, $300,000, then 43,000, and then 30,000. So if I all add all of these up, I get 373,000. So this is my total lifetime cost. Now, if I want for per unit, so per unit will be 373,000 divided by 20,000. And if I find that out, I get my answer as 18.65, which is option A. With this, we have come to an end to this subtopic, which was life cycle costing. In the next video, we are starting with throughput accounting. Thank you so much for watching. Stay tuned for the next one.